In this video I will discuss impedance, series and parallel wiring, single coil and dual coil subs, RMS and peak power, how to choose an amplifier, and how to choose gauge cable sizes. Impedance and resistance are the same thing. Impedance is used for alternating current and resistance is used for direct current. In this situation we'll be dealing with alternating current. Parallel wiring lowers impedance, series wiring raises impedance. However, with series wiring, if you lose connection with any of the subwoofers, you lose power to all subwoofers. So there are single voice coils and dual voice coil subwoofers. The difference with dual voice coils is the wiring options available. For example, on a mono-channel amp, 4 single 4 ohm subs can either have a final impedance of 4 and 1. On 4 dual 4 ohm subs, you can have a final impedance of just 2. RMS, or root mean square, is the maximum amount of power an electrical component can possibly handle continuously without damage. Peak power is the maximum amount of power an electrical component can possibly handle for an instant without damage. Peak power is to be ignored. So I decided for my setup I want two 12s and two 6x9s. Now each speaker has an impedance rating of 4, but if you see here it says the impedance is 2, and that's because these two subwoofers are already parallel wired when it comes out the box. You have to remember when you do parallel wiring, it lowers the impedance, and the RMS rating is 600 watts. Now for my 6x9s, I selected the Boss CH6950s, and the RMS, or power handling, either or, per pair, not per speaker, is 300 watt RMS. So I add 300 plus 600, and I need an amp that can deliver 900 watts RMS or more. So now that I calculated the amount of RMS I'm needing to run my subwoofers, I know I'm going to need something greater than 900 RMS. But also I got to remember that I have single voice coil speakers, and I have 4 of them, and they're each rated at a 4 ohm impedance. So I can either get a final impedance series wiring of 4, or if I parallel wire them, a final impedance of 1. I can't get 2. So if you're looking over here, you're seeing that they have a greater RMS rating, and this is the RMS power, greater than 900, which is good, but also I got to take account that the final RMS cannot be achieved with the speaker setup that I have. So the R2400D is the amp of choice for this situation because it has a greater RMS of 900, or is greater than 900, and the final impedance is 1, and that's what I'll be getting when I parallel wire all of my subwoofers. I've picked up my subwoofer and amp. Now I need to figure out what size gauge wire is required for this setup. Fundamental math is needed to determine the proper gauge. The total power at RMS is needed over voltage to determine the current draw. First, I must understand class types and the voltage from a car's battery. Today with car amplifiers, most common class types are class A, B, and D. Class AB has an efficiency ranging from 50% to 78.5%. Class D has an efficiency of 90% and better. The standard car battery gives off 12.6 to 12.8 volts. When the car is started, the alternator kicks the voltage of the battery between the ranges of 13.5 and 14.5 volts. The 2400D is a Class D amp. Its RMS rating is 1800 watts. I'll multiply that by 1.1 and divide that by the voltage of the car off. The current draw is 157 amperes. With my car turned on, the current draw ranges from 136 to 147 amperes. The reason I multiply by 1.1 is because the amp is at its worst 90% efficient. So for 1980 watts pull for power, 1800 watts are used to produce sound, and 180 watts are converted to heat. I will most likely pay my subs with the car off, so I'll go with 157 amperes. Next is to determine how far my battery will be from my amp. Since my car battery is in the back seat, I will only need 5 feet of cable. Looking at the chart, I can determine what gauge size is needed. Now I figured out the gauge size from my car battery to my amp, but what about my amp to my speakers? All you have to do to figure that out is take the RMS rating of the speakers divided by the current voltage, and that gives you the amperes that you need. So for my kickers, I need a gauge that's 10 or greater. The amp. Now I have my 4 gauge wire hooked up to the power part here. or the positive part. Then I have my remote, this gray wire, which runs to my radio, and when the radio turns on, the amp turns on. When the radio turns off, the amp turns off. You cannot turn on your amp unless you have your remote turned on, unless you could somehow send a power signal there manually. And you have the ground wire, which is this black wire, just connected somewhere in the chassis of the car. You see up here, I have it connected to this part, and make sure you bolt it down. You don't want this thing coming loose while you're driving, so put it somewhere secure and tight. Power my car on, turn on my radio. And now you can see that the amp is on and running. So the next thing we do is hook up the speakers. So you can see that I have 4 wires running to the positive and the negative. The 2 on the bottom are the 8 gauge going into the 2 12-inch subs, and the top is a 12 gauge going to the 6x9s. And if you look up, you can see that they're already parallel wired. I did an impedance reading and got a range of 1.3 to 1.5. Alright, so you see my kicker, 44 WC DCs. Everything's organized. Got my 2400D screwed onto the side of it. Nice little blue LED light. And you got your little settings down here, your level, your supersonic, your bass boosters, and all that stuff. You can look into the menu and do some research online. I'm not going to go too far in depth on that. But I got everything zip tied, organized out. The subwoofer, or not subwoofer, the sub or bass booster controllers in the front. So